Okay, so here we've got a Samsung DVM+4, and if we come over here, we can see that there's 5 units on here. I don't know why there's one MCU. Let me have a look. Okay, it is a heat recovery system. That's why we've got one MCU. We are going to have a look. At this stage there's no codes on the system, so let's dive into it. Oh, look at that. Boom. See that? Look at this. Boom. That tells me someone disconnected a compressor because there's a problem on it. Now this system being the DVM+4 is the earlier model, and the ones that I've got most of my videos on are the DVM-S. The DVM-S, the difference between the two is the DVM-S is an all inverter system. So the compressors are inverters, the condenser fan motor is a ECM, and right here you can see this is the inverter circuit for the fan motor. This one right here on this particular model as well. This one right here is your hub board. On the DVM-S system it's a much longer PC board, and this one right here is your CT compressor board. So this is the two outputs for the compressors, and here is your inputs, and there are the fuses. There's another board in here where your electrical terminals are as well. We'll go ahead and start there. Start by checking incoming power and verifying that our supply is correct, and then we'll check it over here, go through our fuses, and then we'll start ohming out these compressors and see what the issues are. Cool. Alright, let me know what you guys think about my new safety glasses. They didn't have the blue frames, they had the yellow ones, but it's got some nice cushion on the inside, and these are adjustable, and you can also remove these because it's got a strap that you can put around your head, an adjustable strap. Alright, so again, don't assume, go through the process and verify things before you start diagnosing. So let's start by checking incoming voltage. This is a 3-phase system. Alright, apply 1 to 1. Got 395, 396, 399. Check the neutral. Choose one of our eggs. Neutral to 1, 229, 230, 238. Alright, check the that. So voltage leakage. Good. Good. We are good. Incoming supply is good. So what we can do now is go to our CT compressor port and check voltage on here as well. Put this tester on ohms, and let's do an ohm check on firstly let's start with the one that is disconnected. Checking between the windings, and we've got 180 ohms. And we got 277. And then we got 97. Alright, all those readings are excessively high, but the main thing that is very important is you want all of your ohm readings, specifically on 3-phase motor, you want your windings to be within 10% of each other. So the tolerance will be 10%. Yeah, let's put it ground. Let's check this so we can go to the ground. Out. Alright, we got a good ground right here. Okay. Yeah, and we are grounded. We are grounded. So if I put my tester on continuity, I'm getting our own reading, and that one's the lowest. So we got 0.8 ohms to ground, and the other windings are 97 ohms and 180 ohms. So we definitely got a grounded compressor, and that will be this one. Now, when you're working on VRF systems, the thing that you want to consider is the oil contamination. So now we know that we've got a grounded compressor, which means the insulation of our windings is being compromised. So our oil therefore is also contaminated and compromised. So what we want to do is we want to have the system will have to get decommissioned, and we will have to have a look and see what the oil looks like. If the oil, have a look at an oil scale. So for that, consult the manufacturer. But have a look at the oil scale. Have a look at a oil scale and compare it, and that will tell you whether or not you're only going to replace the defective compressor or you're going to replace both compressors. So if the oil is severely contaminated, I'll see if I can put a screenshot up on the video. If the oil is what the manufacturer recommends on these particular units. Specifically, what I'll say is if you're working on VRF systems, go ahead and replace both compressors inside the system. This condenser, although the other compressor is working, replace them both. So now we got to find out why our compressor is grounded. It's oil return issue, causing excessive air temperature, therefore heating up the windings and melting the insulation, shorting out the compressor. If it's an oil return valve that is defective. So those are the things that we will have to check. Alright, so let me give you guys a sneak peek inside here. So there we've got at the back there, we've got a plated heat exchanger. So yeah, like I said, we're gonna have to take an oil sample. This is our oil port. If you had another condenser linked up to this condenser, you would run another line to that condenser. This is the oil port right here. We'll see, man. Maybe we'll grab a sample from here and just have a visual how this oil looks like. But we're gonna have to check the accumulator return valve to ensure that that is functioning properly. So yeah, before we do anything else, that's what we're gonna do. Then we'll have to put on a heat pump bidirectional liquid line dryer. Let's have a look, see what's going on here. Okay. So we'll get one. I'll probably get the one that I normally get, which is comes in 7/8 sweat on. So we'll put a liquid line dryer over there. Bi-directional, very important, because if I show you, look at my service cart out of the way. We are in the parking zone. Oops. In the parking area, and that's why you see, well, not that's why you see this. The reason you see all of this rust is because we're close to the ocean. And as you can see, these units have been painted already to try and protect these units from rusting up bad. So as you can see over here, we have got a bi-directional flow. But if you come and have a look over here, we got a single direction flow. That is incorrect. And if you come over here, you got a single direction flow. That is also incorrect. These systems have got nothing. These ones have got nothing. So what I'm going to do right now is I'm just going to pop open these panels and have a look at the rest of the systems. So here is our VRF systems, and this one I'm pretty much got all the information I need. We're gonna have to replace all these fuses. Depending on the oil, we might end up changing both of these compressors. So like I said, these ones are digital scroll compressors, right? So if you hear that, that is a load on, load off. So these are Copeland's. I think this was the last Copeland compressor Samsung used. After that, they started manufacturing their own compressors, which is in the DVM+ system, which is complete inverter setups. So yeah, let's have a look at this model number. This is a RD120. So this is a 12 horsepower system right here. Yeah, so we got 33.6 kilowatts of cooling and 37.8 kilowatts of heating capacity. How much refrigerant does the system take? There we go. So it's pre-charged with 5 kgs. We'll have to see what the pipe lengths are so that we can calculate the additional charge. So the way you do that, again, check what the manufacturer specifies. This is a 1/2 inch, but this goes up to, because I can see these sizes are not the same, man. These sizes are not. Here we go. So I was checking the wrong line over here. So look. Yeah, this is my high pressure line, and that's my suction line, and this is my liquid line. So liquid line comes over. Alright, so we'll put in a 1/2 inch. I think we'll just put a 1/2 inch flare on with a ball valve over here. That way, if the dryer gets clogged up, we can isolate by closing the ball valve on this side and closing the ball valve that's on the unit. And as you'll see, this port is in the front of the valve, which means it gives us access to this section here. So that way we can vacuum this little section here, isolating it from the entire system. Once we've done vacuuming it, we can open the valve on that side, open the valve on this side. Boom. Alright, fantastic. So that's 1/2 inch and potentially both compressors. So I'm going to go ahead and open these up, and then I'll dive into it. But that's where I'm going to end the video. So I want to thank you guys for watching. Not mega information in this video, but thank you for watching. Alright, so I thought I'd give you guys some bonus footage. That unit I'm pretty much finished over there. So we're going to replace both compressors. We're going to change the fuses out on that board as well. The pressures are looking fairly decent, so I'm fairly confident that there's no leaks. As you can see, low side pressure is at 8.7 bars. So it's just running on the compressor number 2 at the moment. But obviously this unit has a sequence of events, so depending on load, it will start on compressor 1. It'll always start on compressor 1, and after about 5 minutes or so, then it will initiate compressor 2. So when they're using this system, for the first couple of minutes it seems as if there's nothing happening because that compressor has been disconnected. So only once compressor 2 kicks on, there's some cooling happening on the inside. I've checked the data, it doesn't look bad, so for now they are up and running, but we're going to end up having to change that. So right now I've checked out this system. This system has got a 152 error code. This is a heat pump. This is a heat pump and not a heat recovery. So the possibility of cross operation has to be scratched out. So this unit over here has got a defective indoor expansion valve coil that we have to replace on unit address 5. So I've made my notes as I go along. So now we are checking out this system right here, which has got a E403 on U200. U200 means it's the main outdoor. If it was U201, it would mean on the slave condenser. So on this system we got a 403. 403 is a freeze check alarm. Now we're in the middle of summer, and for the unit to give us a freeze alarm on the outdoor seems a little bit weird. So what we're going to do is we're going to have a look at our sensor data and see exactly what's going on. Let's go to our outdoor unit cycle. That will show us our sensors. So ambient 19, 19. Nothing is jumping out that is below freezing right now. So what I'm going to do is I'm going to reset that's on. Let's just confirm that before I do that. Yeah, all the temperatures right now seems fine. So let me go ahead and reset that, and then alright, so the system right here, we got it in cooling operation right now, forced cooling operation, so it's a test mode. This will help us to start the system on full load, so it will disregard the wide controllers downstairs. And if we come over here, you'll actually see that the set point is on 3 degrees on all of the units. But what's interesting is, look at this one right here, our evaporator in temperature on the address 00 is minus 49 degrees Celsius. And as we go down, this is the other one that jumps at me real bad, is 94 degrees on address 10. I'm going to allow the system to come out of safety start. Let's see, okay, it's on oil withdrawal right now. Once it's in test operation, these numbers should start stabilizing, and that'll give me a more accurate displacement of where we are with the sensors. If we've got sensors that are heavily out of range, right now I can see 2 sensors that are out of range. It'll be address 10 and 00. The rest of them, as you can see, the system's starting to stabilize. As temperatures are coming into the positives. So yeah, like I said, let's wait till this is in normal operation, and then we will have a look and see what our temperatures look like. But so far, yeah. And let me show you guys the other big issue that I found. Look at that. That is a single direction valve or full liquid line filter dryer on a heat pump. And this is the slave condenser, exact same one. Alright. So what you want is that right there. You got both flow, both directions. So that'll have to get fixed. Okay. So right now she's running. This is the slave condenser. And this one right here, she's running as well. So let's have a look at our pressure. High side 25 bars. Low side 6.7. Little low. Let's give it some time. I think it's in safety start as well. This is the slave condenser to that unit. We just started this one up. Well, not just, we started this one after that one. So yeah, let's give it some time. Pressure's already improving, so that's good. So at this stage I see us doing some repairs on this system and on that system right there. You guys are getting some bonus video footage today, and here's my notes that I've got so far. In fact, we are doing some repairs on this unit as well, but on the inside, on the indoor units, one of the respective indoor units linked to the system's got a electronic expansion valve coil that's gone bad. Still in oil withdrawal. Yeah, you guys are getting some great footage today, man. Yeah. 20 horsepower condenser. This is a 16 horsepower condenser, so in total you got 36 horsepower. Put that into kilowatts, you've got 40, let's say 45, and so you've got about 90, you've got 100 kilowatts of cooling capacity here. That's a lot. Alright, so I'm moving up and down. Everything still sounds good. We got 2 compressors running here, 2 compressors over there. Each of these systems, let me just make sure based on the model number, have got 3 compressors. I think this one's got 3. This one might just have 2. Alright, so test operation. Let me give you guys a closer look. So we in test operation now, so if we go ahead and have a look at our indoor unit data, yeah, see those temperatures? Most of them are out of the negatives. There's one more that's at -3, but that's minor. I'm not worried about gas pressures or anything, because if you have a look at my EEVs right here, they're very happy. We're only at about 120. The highest is 100. Oh, they're close to 215 steps, and these typically go all the way to 1,500 steps. That's maximum. So we definitely got that sensor that needs to be replaced, and the one right on top. Fantastic. So we more than likely will have to get that indoor model number and get that sensors changed out. Alright, let me move on to the next condenser. I don't know if I'm going to give you guys some footage on that one though. Yeah, you guys seen too much, man. I need to keep that for next week. Alright, but thank you guys for watching. Alright guys, so on the north side system, what I've noticed was there was no current draw on the slave condenser on compressor 1. There is voltage across all fuses. You can see that's a fuse that has been changed. Same thing. Found the compressor unplugged, and I've dived in a little bit deeper. As you can see, it's a Copeland scroll R410A system. It's not grounded, but we lost one winding. It's open circuit, so yeah, we're gonna have to replace that. And I'm a little bit concerned because my high side pressures were excessively high. The units are reading 19° ambient. Like I said, we're in a parking basement area, so we're covered. There's no direct sunlight here. It is quite chilly. It's 19° ambient, and we had a head pressure of 24 bars, which is fine, which was not the thing that concerned me. We had 24 bars of head pressure. The thing that did concern me was my discharge temperature. Discharge temperature was over 100 degrees Celsius. Came down to about 96 degrees. Right now it came down even more. But that is a concern. The pressures are looking good, but that's a concern because of contamination. We potentially have contamination in the system. So we will have to have a close look on that. As you can see, low side pressure is about 8 bars right now. So yeah. So I guess there's some more quotations to go out. Alright, some bonus footage once again. I told you guys, man, damn. I'm blessing you guys with a lot of footage today. Alright.